When a light meets a boundary between one medium and another, part of the light can be reflected and part can be transmitted. The reflected light, which of course is the reflection that you're familiar with in the mirror, this part bounces back at the same speed, but may be inverted or polarized. The transmitted light, the part that goes through the medium, may speed up or slow down depending on the properties of the medium. The light ray looks like it bends at this point, and the bending of the transmitted light is called refraction. Refraction is the bending of a wave when it enters a medium where the speed is different. A ray of light passing from one medium to another may speed up or slow down depending on the properties of the medium, remembering that wave speed is dependent on the inertial property and the elastic property. This physical phenomena explains how images are formed by lenses, how the image in the eye is formed, and cameras, etc. And we'll talk more about this in the next video. The amount of bending depends on the indices of refraction of the two media, and that's described by something called Snell's law. Reflection, on the other hand, is just the light bouncing back. Here's two nice pictures of reflection that I took in Japan. Are they the right way up or upside down? So how do we quantify reflection? Well, the reflected wave will always bounce back at an angle to the surface equal to the angle at which it hit the surface. This is summarized by saying that the angle of incidence equals the angle of reflection. This is useful when you're playing billiards or pool because the same law applies. If I draw it here now, if this is the mirror and I have some wave fronts going in, I'll draw a line perpendicular to the wave fronts, and this is the light ray. This is the angle going in, the angle of incidence. Now, if they get reflected and come back out again, we get these lighter green wavefronts here. I'll draw a line through here. This is the light ray, and this is our angle of reflection, theta out. So the law is that the angle of incidence equals the angle of reflection. This is true for all surfaces, not just mirrors. So this is even true for what's called spectral reflection, where the light is scattered off in all directions. But if you look closely at a microscopic scale, the angle of incidence will still equal the angle of reflection.